Good morning, everyone. On behalf of City University, I, Apurva, Project Officer, would like to take pleasure to welcome Dr. Arvind Dhingra, who is a distinguished professional with an extensive background spanning over 27 years in both industry and academia. Holding a diverse educational portfolio, he obtained his degree from MREC, now MNIT Jaipur, followed by an MBA from IGNO and MTech from PTU, and culminating with the PhD from NIT Kurukshetra. With research career, he has authored over 85 papers across national and international platforms, alongside delivering more than 80 keynote addresses at esteemed conferences worldwide. Certified as an energy auditor, Dr. Dhingra has been instrumental in leading as the executive director of STEP GNDC since 2018, where his guidance has fostered numerous successful startups. His academia interests encompass energy management and audit, power quality, and entrepreneurship. Currently serving as the chairman of the Institute of Engineers India, Ludhiana Local Center, Dr. Dhingra continues to drive innovation and excellence in his field. So today he is going to deliver the session on the topic process of innovation development, technology readiness level, commercialization of lab technologies and tech transfer. Without any further delay, I hand over this session to you, sir.
Thank you, ma'am, and thanks to the IQSSL and IAC of City University for inviting me for this lecture. Thanks to the Chancellor, sir, also for giving me this opportunity to interact with your students. Although I would have relished to be with you in person, but due to certain commitments and back-to-back sessions today, I have to be online only. Yeah. So thank you, the authorities of City University, Chancellor Sir and Pro VC Sir, for giving me this opportunity to interact with the students on this topic. I would have loved to be with you in person for this particular session, because this session is a little more interesting when you are doing it face to face rather than doing it online in a virtual world. And but due to certain commitments, prior commitments, I couldn't be there. But let me see if we can do justice to what we are going to talk. Uh, Friends, innovation is basically introducing something new to the market. It could be a new product, it could be a new service, it could be a new idea, a new process, something which the market wants to make make the life of the people easier. This is basically what we're talking of. That is the thing. So how does the innovation happen? It doesn't happen overnight. It takes a lot of time to develop a technology and to deliver it to the market. There are a number of stages involved. It's not like one fine morning you get up and you get an idea, brilliant idea, and you want to present it to the people concerned. So it's just like something which you have to develop on and dwell on basically, so that the things work. So just let's talk of technical readiness level. And why we're talking of this technical readiness level is because these are the ones which tell you, when you think of a product or a service or an idea, when is it ready to go to the market, and how we should work on it. This is the basic parameter or the basic evaluation guideline which tells as to how much funding can be given to you at one particular product line. Right? So just so just to take out what is happening right now, what is the relevance of your research? You people get enough ideas, or you are working in a lab, you get an idea that this should be done like this. What is the relevance of that idea? Is it useful to society as a whole, or is it just an idea which is out of the box? And what is the outcome and future of the research project, your ideas? See, what happens is most of us would be making a project in your final year of engineering or final year of your graduation, and it could be innovative also, and you think of it. But what happens after you finish off your graduation or your this thing degree, that project idea gets buried. Why? Because nobody else is ready to take it up, and it's not been refined to a level which it can be taken into the market. Now, will your idea be used by anyone? Can't Can it be used for any other similar areas or domains? Is it only domain specific? For example, it could be it's specific to what you can use it in city university only. You cannot use it in any other place. Or it could be an idea developed by city university, and it could go out, and everybody in the world could have a look at it. So, is your research industry friendly, or can we take your ideas to the industry or company? Can the company do something with your idea? That is also an important point. And when is the right time of building a venture from your tech ideas? Now, here there is an interesting example. You would be knowing that digital cameras were invented way back in 1970s, and they failed badly. Then came Kodak, took over the photography market, and we used to have those reels, photography reels, which had only 36 exposures, and you had to stand in the line to get it processed to see the photograph. And Kodak almost was holding 80-90% of the share of the market. But the digital camera, which was invented way back, came back into the picture. Some modification happened, and it is now available in every mobile phone, and it is shining like. And Kodak is nowhere. You have to think of right time when you can launch that product. So the plan is, how can we make our idea is technology transfer and commercialization. See, if I want to earn money out of my research, I need to do technology transfer. Basically, the process of transferring knowledge, technology, and product from an inventor to other organization, entity, or from one purpose to the other. You could have developed one technology, it could be used in somewhere else. See, for example, microwave oven was not developed like this. Microwave was developed by some doing research for some space, and accidentally found out that you can this can be used to heat the food. So microwave came in that way, and then okay. So technology readiness level, these are assessment. It's an assessment tool helpful throughout the life of a research project or an idea. What based on that, it is the third way. It measures the maturity level of technology. How mature is the technology? How good that it is suited to the market, or is it a crude product, right? Defines the stage and growth of technology. What is happening right now? Like, for example, in mobile phones, we had two to plan the development of a particular technology. How a particular technology can be developed, taking specific decisions regarding the technology as to what modifications are required, what should be done to do that. And there are 9 phases to define the stages of technology, which are called as TLs or TRL 1 to TRL 9, technology readiness levels. It's acquisition phase. Acquisition is when, see, I have developed an idea. I got an idea that I need something to write. So I developed a pen, or I thought of it as a pen. So now, if I have made that pen and it is ready to go to the market, that there are a number of stages involved in that. We'll talk of them one by one, and that basically defines the technology readiness level. TRLs allow engineers to have a consistent datum. Datum is the base of reference for understanding technology evolution, regardless of the technical background. TRLs are designated through a technology readiness assessment (TRA). examination, basically, which examines the program's concepts, technology requirements, and technology capabilities. Right. Then TRL is a very useful approach. It helps in general understanding of the technology states. As to what, how good is the technology right now? Say for example, if you talk of electrical vehicles, the first electrical vehicle, if you see, which could move 100 kilometers in one charge, was way back available in technology. She says your idea is very good. I want to fund you, but what fund should I give you right now? For initial funds, I would just, if I want to make the first replica or first, I need only the help to buy material from the market and get it processed at certain another location. That is one type of funding. Then, if I am going to market that product or I'm going to make multiples of that product, I might need my own machinery. There could be another technological funding required. Then decision making with respect to technology transfer. Should I license it out? Should I give it as a whole? Should I transfer the copyright to the people? Should I give my IPI to somebody else? This is also a very crucial decision in the phase of TRLs. A scale to measure the maturity of technology and plan a path. How you are going to move from one stage to the other, how the technology is going to move from one stage to the other. Right. Origin, how does this technical readiness levels or technology readiness level originate? There are systematic metrics that provides an objective measure to convey the maturity of a particular technology. Originally, they were developed by NASA, but with a little modification, getting rid of all the in-space qualifiers, for example, because they were for space, so everywhere they had written in space, this is happening in space, this is happening in space, this is. So if you remove in project, so Department of Defense has adopted this metric to evaluate. The U.S. Department of Defense adopted this metric to evaluate the readiness levels of new technologies and guide their development towards the state where they can be considered operationally ready. Operationally ready means everybody can use it, is easily available off the shelf. Then there was a General Accounting Office in US, which was set up here on recommendations. And this, in a 1999 report, they showed that the failure to properly mature new technologies in science and technology or laboratory environment, technology is not ready. And I see, if I want to make a spacecraft, I want to send people to space. If I do not have the technologies to make a spacecraft, it is going, and I'm going to research it right now. It might lead to cost and the time overruns for doing it. Right. So in their report, the GAO, the General Accounting Office, found out that separating technology development from product development is a best industry practice. You can't say that this product is good. Product might be good, but it might not be supporting that particular technology. See, Nokia 3310 was also a good product, technologically not advanced, but product was good. So the report puts it this way: maturing new technology before it is included on a product is perhaps the most important determinant of the success of eventual product or the weapon system. Before you make the product operationally ready, before you say that this is market ready, before you launch the product in the market, you need to see that the technology is mature enough, it can handle. Otherwise, it might lead to problems. Examples could be, say, for example, if we launch the electrical vehicles and two-wheelers without any testing and all, it might lead to blast of the vehicle and might cause damage to life and property. This statement says that you must be certain that a technology is mature before including it as a part of product or weapon system. So GAO recommends that the Secretary of Defense adopt a disciplined and knowledge-based approach of assessing technology maturity, such as TRLs, DoD wide, and establish the point at which a match is achieved between key technologies, weapon system requirements, as proper point for committing to the development and production of weapon system. But since it was being developed by US Department of Defense, So it is more of the references to weapons, but it is actually true for any product, any kind of a service. So these are the nine technological readiness levels, starting from 1 to 9. 1 to 5 are basically R&D levels. 6 and 7 are also called as the valley of death. Why they are called the valley of death, we'll discuss a little later. 8 and 9 are in the deployment stage, wherein they are market ready. So the first is, let me just explain them in examples. TRL1. Here the basic principles are observed and reported. Just like a few basic principles of gravitation you could observe, basic principle of pneumatics, hydraulics you could observe, and you can say, okay, this is neat. This level represents pure research. There really isn't even a particular piece of technology in the question. No technology, only idea, only ideation. We might be studying basic properties of materials or noticing what works well in a Warcraft 3 or any other product. Then there is a DRL2, technology concept and or application is formulated. Here, you formulate the concept, you formulate a thesis that if I do this, this will happen. And this is, oh, it's an idea. This level represents taking our observations from the laboratory and coming up with some sort of practical use for them. What is the practical use of those observations? What we have made in the laboratory. Things here are still speculative. Speculative in the sense you are just okay, yeah, this is going to work. This is going to work. This might not work. We could be thinking about superconductors or real-time strategy games. Then TRL3. This here the analytical and experimental critical function and or characteristic proof of concept. Here you try starting building the proof of concept, not build the proof of concept, but you start it. You try to gather the material for it. You try to find out what has to be done. Say, for example, if I have a circuit diagram to make, or if I have a machine to make, what is going to be the diameter of the wheel and all that stuff. So development has begun here. All we are trying to produce is the proof of concept for the stuff we came up with in TRL2. So we had an idea, we are not trying to develop a product. Getting an experimental process to work in the laboratory setting, for example. This is one of the examples for this, right? And TRL4, if you talk of, it is component and or breadboard validation in the laboratory environment. Now, what you do, you try to assemble and in the laboratory environment, which is controlled, which is wherein you can have exercise anything that is there. And this is called also called as a ghost spike, gold spike. Gold spike means you can be at the cusp or at the point where it is you're going to earn money out of your idea, earn money out of the technology. So we take our proof of concept from TRL3 and we integrate them into a low fidelity version of the system. We came up within TRL2 a playable demo for the project pitching purposes. For example, it is a example for that, right? Then coming down to TRL5, here the component or the breadboard validation in the relevant environment, or it is the alpha version. You would be hearing when you are talking of startups or when we are talking of participating in a competition, the judges innovation competition, people would ask you whether you are alpha stage or a beta stage, alpha stage trials or a beta stage trial. So here the you come out of the laboratory and you try testing on a certain strata of society or a certain test people which are going to use them later in in the environment which is actually physical. So this version is robust enough to deal with the real life conditions or at least a decent simulation of those conditions. Testing something in vacuum or a playable demo that you could bring to a conference for people to try out. So what you do, people would put out some things for people to try out. So initially, when we are launching a product, for example, a shampoo, hair shampoo is launched, they go to the hair salons and they put it on the counter and tell people to use it for free. This is the TRL5 stage of that particular shampoo, alpha trials on actual people. TRL6 is beta stage, wherein the system or subsystem or prototype demonstration in the relevant space, ground space. Now here, I do not have a selective audience, but I have a group of audience. Any model or prototype is now well beyond the jerry-rigged TRL4 version. At this point, testing is happening in real environment. Beta testers are called in, or you have to throw in on a shuttle and try out it in space. According to NASA, this step is driven by management confidence than actual technical requirements. So here, the people behind the technology should have the confidence that yes, this is my technology, this is going to work very work properly. TRL7 system prototype demonstration in space environment. Now here, what you do, you have got a prototype ready. Why we are talking? Because if the trials in beta version fail, or if your system demonstration fails, the product you'll have to go back to TRL level 1, again come back to TRL 4, 5 to be ready for TRL 6 and 7. So each stage has, it is just like climbing a staircase. You can't climb the last stair before you climb the first one. You have to climb the first one first, right? So system prototype demonstration in the space environment or things in space, not mapping very well to the project outside of NASA. This level is for purpose of assuring system engineering and development management confidence. Not all technologies need this level of assurance. One example of one that does not and does would be Mars Pathfinder rover, which is a TRL7 technology demonstration for future Mars micro rovers of similar design. Now, what happened? They developed that Mars micro rover and they wanted to put it, but they have not put it right now. Now they have tested it like this is going to be the condition, this is going to be the possible condition on Mars, and this is going to happen, right? Then TRL8, actual system completed. Now here the system is complete. It is ready. And it is flight qualified. You can say anyone who wants to come and try is welcome through test and demonstration, ground or space, and it is gone gold. You're ready to market it. You're ready to produce number of them. By definition, all technologies being applied in actual systems go through TRL 8. At this point, you have completed a theoretical first unit. You have got the first theoretical unit, which is ready for, or otherwise gotten a product ready for prime time, version first. If any improvements are required, they will be suggested here in TRL9. Actual system, which is flight proven through successful mission operations. You have done number of operations before. Now it is ready. Now it is mature technology. It can be launched into the market. Kit tested, mother approved. Somebody had tested, but mother has approved. Okay, it is okay. So once your product is in use, it is TRL9 by definition. This TRL does not include any expansions or upgrades, which have their own TRLs as appropriate. See, now here you are not supposed to include any upgrade of this technology. Say, for example, I had a mobile phone, you you added a camera. No, you have to go back to TRL first to come back to TRL9, right? Real usage of TRLs in aerospace and high technology companies. TRLs are used to determine if the status of technology, if this and what is needed to mature it for operational applications. Now, what are the efforts required? In what direction should you work? What research is required? You are building, suppose, an aircraft. You can go in for materials, or you can go in for technology. You can go in for fuel and number of other things. So it is used for both hardware and software technologies. Processes and software tools are judged to the TRL metric to help them mature. Try to fit the product process or the software tool into the TRL metric so that you can have a product which is mature for the market, available for the market. The DoD TRL definitions are Department of Defense basically. Definitions is a refined set of previous NASA's set of TRLs. The Defense Acquisition Agency is the primary user and advocate of TRLs. They have a complete program called Technology Maturity and Technology Readiness Level Assessment Program. Now, this is the NASA graph as the earlier graph, but what they have done, they have put it on the basis of what they are requiring in space. Now, you see in TRL1, it is the basic technological research. Somebody wants to go to space, spacecraft should be available. Then doing research on what kind of fuel to use, what kind of material to use, developing the technology on that, what is the latest available here, then technological demonstration is required, then subsystem is required, and system launch is required, right? So this graphic illustrates the progressive steps necessary to mature technologies and integrate them into subsystems, systems, and programs, right? This whale chart, this is a very important whale chart as far as NASA is concerned. And they say what is happening. See, they've this is the utility of the product and this is the timeline of operation, right? So what has happened is DoD, Defense Department of Defense milestones. These are NASA milestones and these are the TRL levels. Now, what happens? They say that as a child is born, then there is childhood, there is adolescence, then there is adulthood, then there is maturity, old age, and finally you have to go from this earth. So basically, the first stage is concept refinement. From the thought process, I want to bring it down to a piece of paper on design on paper. Then I try to develop the technology. From child birth to childhood, I need to learn certain things. I need to find out how to stand, how to take a glass water, not to touch a hot plate, right? Then system and development and demonstration is happening here, and then there is the production development, and here is the operation and support. So DRL levels 9 and up to adolescence, and NASA milestones are a little further also because they do not want to risk anybody going into this space without the actual feeling of it, right? So, defense acquisition definitions of TRLs, basic principles, TRL 1. Basic principles are observed and reported. It is the lowest level of technology readiness. Scientific research begins to be translated into applied research and development. Examples might include paper studies of technology's basic properties. What is happening right now is like you have got an idea and you see here, this is something available to me, I can use it. Technology concept and or application formulated is TRL2. Here the invention begins. Once the basic principles are observed, practical applications can be invented. Applications are speculative and there may be no proof or detailed analysis to support the assumptions. Examples are limited to analytic studies. Then there is TRL3, which is analytical and experimental critical function and or characteristic proof of concept. Here, active research and development is initiated. This includes analytical studies and laboratory studies to physically validate analytical productions to separate elements of technology. For example, here what we are trying to do, we're trying to break down the technology. Yeah, this is okay. This I need to improve upon. This I don't need to improve upon. Examples include components that are not yet integrated or represented. Then in 4, component or breadboard validation. Here basic technological components are integrated to establish that they'll work together. You try to sum up everything and you say that this machine is going to work. This is relatively low fidelity compared to virtual system. Examples include integration of ad hoc hardware in the laboratory, then component and or breadboard validation in relevant environment. Here, the fidelity of breadboard technology increases significantly. The basic technological components are integrated with reasonably realistic supporting elements so that it can be tested in a simulated environment. Now here in TRL5, you try to validate in a simulated environment. Then 6, system subsystem model or prototype demonstration in a relevant environment. Here, representative model or prototype system, which is well beyond that of TRL5, is tested in a relevant environment, represents a major step in the technology demonstrated readiness. Examples include testing a prototype in a high fidelity laboratory environment. Here, we are still not into the field up to TRL6. TRL7, system prototype demonstration in an operational environment, prototype near or at the planned operational system. Here, basically, what is happening is this is now the development of prototype. It represents a major step up from TRL 6, requiring demonstration of an actual system prototype in an operational environment such as an aircraft, vehicle, or space. Examples include testing the prototype in a testbed aircraft, right? Then TRL 8, actual system is completed and qualified through test and demonstration. Technology has been proven to work in its final form and under expected conditions. In almost all cases, this TRL represents the end of true system development. Examples include developmental test and evaluation of the system in its intended weapon system to determine it meets these if it meets these specific specifications. Now here, final form is almost coming up, and you are trying to integrate whatever components are available. In ninth TRL 9, actual system proven through successful mission operations, actual application of technology in its final form and under mission conditions. Examples include system under operational mission conditions. So examples, there are many other examples of technology going through many years of adaptation prior to its reaching its broad applicability. What you see, okay, in the image in the next slide, may hardly seem as hardly recognizable mechanical device. What is on the right is the contemporary version. This is the first computer mouse prototype invented in 1964 by Douglas Engelbert of Stanford Institute. You can just see on your left, if you see this part, this is the crudest part, a TRL2 part or TRL3 part, and this is TRL9, right? So how can you calculate the TRL? Say you say that, sir, I have made a very good project and the technology is ready to fly, but how it is to be done? You have got to have run a technology readiness assessment test that examines the program concepts, technology requirements, and demonstrated technology capabilities. TRLs are based on scale from 1 to 9, with 9 being the most mature technology. Assessing the TRL, assigning a TRL rank is not a quick task. You can't say that this belongs to TRL 2 or 3. There could be an overlap somewhere. There could be you could not be putting it at the right level just because your thought process and the expert's thought process might differ. So there are some serious questions that need to be answered and backed by technical data regarding the current status of the technology. Is the technology widely commercialized? Is the technology demonstrated in the form of a target system? Is the technology demonstrated in the relevant scenario? Tools used, scientific publications in refereed journals. So you try to project your research in a refereed journal, which is reviewed by certain experts in the field or certain people who are already working in the field, and they can vouch for it. Yes, this technology is going to change the world. It is, or it is a viable technology. Then there are certain government agency reports which you can refer to for assessment. Company news releases, they may withhold the technical details which are their proprietary but might release other details. And they can tell, see, for example, any soap company will not tell you the formulation of the soap, but they will tell you that this is the new soap we are launching. Then public news, web blogs, ads, etc. Personal communication with experts, researchers, and entrepreneurs. Addressing the TRLs, a systematic addressing of TRLs is required, allowing a technology to evolve from conception through to the research, development, and deployment. See, from the ideation stage, you are allotted a major project by your guide or a mentor or your class teacher, and then you think of it, how do I develop it? No, there is a thought process which goes beyond it. ठीक है, universities along the government funding resources focus on TRLs 1 to 4, whereas private sector focuses on 7 to 9. So 5 to 6 is basically the valley of death. You could go either way, plus or minus. The term valley of death represents often uh, neglected addressing of TRL 4. For example, some suggestions came in TRL 4 which are neglected, that would lead to valley of death. That means your product cannot progress further, right? And for startups, what is to be done? TRL provides a structured roadmap to evaluate the progress and readiness of the technological solutions. Say, for example, you want to start a service business. You say, sir, I will do this, that, the service will be provided like this, but you do not have the background run. You have not run the background. You have not found out what the customers requires or what the market requires right now. So it could be you have to find it out where you have to fit that in TRL levels. So by aligning their development milestones with the TRL levels, startups gain clarity on the necessary steps to advance from initial ideas to full-scale implementation. So you can just have an idea and go into full-scale implementation. Uh, these two terms usually people use TRL, MRL, and HRL. So technology readiness level refers to the readiness of the product, which is a tangible asset, whereas a machine readiness level of a production process, it is an intangible asset. See what is happening, how is the machining been done, what machines are being used, it is intangible. Thus, TRLs and MRLs indicate how ready our product or process is ready in its scale for development, whereas HRL indicates the human readiness level, right? And CRL also indicates the customer readiness level. Human readiness level, are the humans ready to adapt to that technology? Are they comfortable with that technology or not? Use of TRL approach has proved to be useful tool for general understanding of technological status, risk assessment and management, as to why should I launch it, should I not launch it, will it bring me profit or not, will it not endanger the life of other people, decision making with respect to technological funding. This is also done. So I have a small YouTube video for you to play. Just one moment. I'll come down to that. I'll play that video for you. Just one moment. Just one moment. Just one moment, friends. Just one moment. I'm just getting that.
तू मारा मैं क्यों मार लगे ना 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 अच्छा मैं तेरे मारे
All right. So we're back. Any questions? Anybody has any questions? You are welcome to ask. You can put it in the chat box also if you want to put it out.
बहुत ही तो
Any questions anybody has? Or we can wind up for the day if you want.
Hello, sir. Am I audible to you?
Yeah, ma'am, audible.
Okay, sir. Sir, might be, I think there is no questions from the student side. So we have to wind up this session.
Yeah. It would have been better in person also, but somehow or the other I couldn't make it today. I was trying to make it, but there were a lot of
Actually, sir, because
students.
of the virtual session, it might be create ecosystem also for
Yeah.
that if we put on the mics. And thank you very much, sir, for sparing your valuable time
Welcome.
for our students. And I'll be sharing your award of appreciation, and
Thank
I'll
you.
come personally at your office and hand over
Thank
to
you,
you,
ma'am.
sir.
It's been a pleasure. It's been a pleasure talking to you all.
Thank
Thank
you so
you.
much, sir.
Thank
Thank
you.
you.
Thank you very much. Bye bye.